Hi everyone, this is Ryan from AIS, and in this video I would like to discuss how to compile and run Bareflank on Ubuntu. To start, we're going to do our test from a VMware workstation virtual machine. We do support nested virtualization in some cases, assuming that VMware actually supports it. In this particular case, the demo I'm going to show works perfectly fine. So to start, what I did is I installed Ubuntu in a test virtual machine. This is Ubuntu 18.04, and I've installed Vim, SSH, and Git, and that's it. Then from there, I have SSH'd into my virtual machine using a terminal. So the very next step we're going to take is we're going to install our packages. So this is all that's needed to get the build environment up and running on Ubuntu. If you happen to be using Arch Linux, then we also provide the commands here. These are the two operating systems, Linux operating systems that we support, as well as Windows and Cygwin. All right, so we now have a fresh system with all the packages installed. So the next thing we're going to do is we're going to create a working directory. I'll explain later why a working directory can be very useful. Normally, you wouldn't do that when building a CMake-based project. All right, so like any CMake-based project, we support the ability to essentially just create a build folder and then run cmake ... and then from there we'll run make. Now what you'll see here is that it is actually downloading all of the dependencies that the project has, and it will then go ahead and verify those downloads hash values to ensure that you're getting not just the right version of the dependency, but also that it isn't corrupt in any way during the download. But more importantly, the build system is smart enough to know when those packages change. And so if, like for example, we do an update of these dependencies and you run make, your build system will know that that has changed and pull down the latest and greatest. All right, so from here we can run make. Actually, you know what? Before we run make, why don't we check out make info? So with make info, you can use this to identify all the different make commands that are provided by the build system. This is a dynamic menu, so as you change various different settings within CMake, you might see some of these come, you might see some of these go. So make info can be very useful for ensuring that your build system is set up properly and you have the right commands. But also, if you're going to use, say, like an extension that we provide or that you provide, there might be additional commands that get added. All right, so let's go ahead and compile. This will take roughly about 45 seconds. Now, one of the things you'll notice is that the build system will actually start to compile both binutils and newlib. So on Linux-based systems, one problem that we've run into is that not all distributions compile their binutils with support for sysroot, or specifically being able to change the sysroot within the linker. And since we're cross-compiling, we need the ability to do that because we're going to change the sysroot of the virtual machine, or excuse me, of the VMM, the virtual machine monitor. And so we have to actually compile our own version of binutils. We're going to do it so it's native to the system like anything else. The only difference that we're doing is we're just adding that sysroot support flag so that we can then build our own sysroot. All right. That's it. So that's all it takes to basically compile the hypervisor. from here we can actually start to run. Now, two other things you may have noticed while this built is that it built, once again, new lib. That's our version of libc that we're using. And then from here, you can see that it goes and compiles right here, libc++. So this is the version of C++ that we're using. And we usually update those packages once a year. So we do keep them up to date. Right now, I believe the project's based off of lib C++ 6.0, but as time goes on, that'll change. All right, so the next thing we have to do to run the hypervisor is we have to go ahead and build the driver. The driver itself is needed for actually launching the hypervisor, because the hypervisor itself needs root privileges. It actually needs ring 0 access. And so the driver is really sort of the jumping off point to do that. So the driver is actually a very small piece of code. All it really does is it has an elf floater built into it that allows us to take our self-contained elf binary, load it into memory, relocate the binary as needed, and then execute it. That's it. Now, here you can see that if you run make driver build, that will actually build the driver. You can then do make driver load, and that'll load the driver. So now our driver is loaded. We are ready to essentially go ahead and run Bareflank. There are a couple other driver commands. There is make driver unload, and then make driver clean, and then make driver quick, which does all of them. So it does an unload, it then cleans, it does a fresh build, then it loads, and then you're done. All right, so from here, if we do make info again, you can see there's a whole bunch of different Bareflank manager specific commands. So BFM is our user space application that's used for managing the hypervisor from the OS. You can see it in the prefixes folder. So if you go to user space bin, you can see BFM there. We can then say execute that executable, and you'll see that basically the same type of commands are there as well. So all we've really done is we've exposed Bareflank Manager to the build system so that you don't have to go through and type in all these paths and everything to get to it. You can just do make, load, whatever, and you're done, good to go. All right, so from here we're going to load the hypervisor. All right, so the hypervisor is now loaded, and then we can go ahead and start it. And now the hypervisor started. So we are now running Bareflank on the OS. So it's important to understand, and we can do a make dump to see this, that the way this works is that the Bareflank itself has rooted the operating system. So it's very much like our VMX rootkit in this particular case, where it essentially takes control of the system and then continues to run the OS, in this case Linux, inside a virtual machine from this point on. So now everything I do is running inside an actual virtual machine, and it allows us to monitor that OS however we would like. I can also run make status. This will basically give us a different point of view with respect to how it's running. So it just gives us essentially a quick status update, and obviously saying that it's running. I can then say make stop, which stops the hypervisor. So now Bareflank is no longer running on the system. So this essentially uninstalls in a way the hypervisor and gives the host OS back the system. And so now now Ubuntu is no longer running within a virtual machine. And then I can also do a make unload, which will unload the hypervisor. And then just like with our driver, there is a make quick, which goes through and does all of those commands. And as you can see here, we're running within a virtual machine again. There are a couple other ones like make cycle and make oops, which are really more developer tools. You can also clean the build system and do a rebuild if you want. Once again, those are more developer tools. And so now that we've gone through this, let's discuss the better way of actually compiling Bareflank. So if you recall, I had talked about building a working directory. Well, the problem with doing the typical cmake ... make method for cmake is that we have some dependencies and we have a lot of different configurations that you can run. And so the better way of actually setting up a build system for Bareflank is actually to create a working directory, and then from there making a cache directory and your build directory here. So if you see this would be what your working directory looks like. From there, you can copy a example configuration that we keep up to date and maintained as the project advances. And this configuration file, which we're going to call cmake within the working directory. So I said we're calling it config.cmake rather. This is what we're going to use to actually configure Bareflank to do all sorts of various different things. So in this particular case, we're going to enable developer mode, which gives us access to a whole bunch of other tools that can be used for creating a pull request. But in here, we've also got several different examples. You can change what target you actually link as the hypervisor itself. You can leave warnings on. There's a whole bunch of stuff in here that's very useful. And so this is usually a good starting point for any build system. All right, now from here, if we go into build, we can then now just run cmake again against the hypervisor, and it will not only download all of the dependencies now to your cache folder, but it will use the configuration file, as you see here, for its config. So all of the various different settings that you can set for Bareflank are now being set from here. The beauty about having your cache folder inside your working directory instead of inside your build folder, which is where by default it is set, is that you can now wipe out your build folder and build again, and you don't have to re-download these files. So once you've done it once, you're done. So it's much more convenient because then essentially you can build Bareflank without having to have an internet connection, which is very helpful. As you can see here, it came back and complained because, like I said before, this was a brand new install of Ubuntu 18.04, and so I installed the packages. Clang Tidy is an optional package that's really just used for developer mode, and so we have to actually have that installed to be able to continue execution here. All right, now that cmake has completed, we can go ahead and build the hypervisor. Now this is going to take a little bit longer because we have developer mode turned on, which ultimately turns on all the unit tests. So we're going to not just compile the VMM, but we're also going to go ahead and compile every single unit test that's used for the code. Now our project, we maintain 100% code coverage within the open source project itself. So there's a lot of tests here that need to actually get compiled and executed. The other thing that we do within our CI is we validate quite a bit of things like code formatting. We use A-style to do that. It's not perfect, but it's at least consistent. So although the code style might not be exactly what we all agree with, what's nice about it is that it's at least consistent across the entire code base, and it can be enforced through the CI, which we really like. We also leverage static and dynamic analysis. To do static analysis, we leverage Clang Tidy, and we have all sorts of tests within Clang Tidy that we do. For example, we ensure that the project is C++ core guideline compliant using our tests, as well as cert compliance and high integrity C++ compliance. We also obviously ensure simple things like readability, performance. Pretty much every test that Clang Tidy offers, we validate against, except for formatting tests, which are specific to the LLVM project or other projects that are leveraging it. And then for dynamic analysis, we use Google's sanitizers to do that. All right, so the hypervisor is now fully compiled. So we can go ahead and run our unit test, which will test the hypervisor to ensure that it's functioning properly, or at least the best we can. Now that our unit tests are complete, we can go ahead and run make format. This will ensure that all of the code itself meets our formatting guidelines with A style, like I said before. And you can also run make tidy, which will do all the static analysis checks. And like I said before, the make info command is dynamic. So now that we're using developer mode, you can see that there's additional options that are available. And well, that's pretty much it with respect to building and running Bareflank on Ubuntu. In other videos, we'll go over things like how to extend Bareflank, how to build it for Windows on other platforms, and then go through other various examples that we have for how to leverage the APIs within our SDK. Thank you for watching.